So the next problem that I'll be doing is number 7. I recreated it to read a particle travels along a line. Its velocity in meters per second is given by v of t equals 4t squared. Minus 12t. And so I got part B of this problem wrong, but I'll go ahead and do part A and B because part A leads to part B. So to find the displacement from t equals 0 to t equals 6, I wanted to look at the graph of the function first. So I did this by factoring out 4t from this function, and that would lead me to 4t parentheses t minus 3, and by equaling this to 0, we can see that the zeros of the function is t equals 0 and t equals 3. And so because we know that the function is concave up parabola, this is what the graph looks like more or less. This helps us find displacement because we now know where the velocity is negative and where it is positive, which is greater when x is greater, or when t is greater than 3. So now we can split up the integral into two parts because finding the integral of velocity gives you the position function. We can do the integral of 4t squared minus 12t in the boundary of 0 to 3 because that is where the function is negative, and then add that to the integral of 4t squared minus 12t from 3 to 6 where the particle has a positive velocity. So taking the integral of this, we would get 4 times t cubed over 3 minus 12t squared over 2. This is still within the boundaries of 0 to 3, and add that to the same. We can simplify this to 4t cubed over 3 minus 6t squared to the boundaries of 3 to 6. After plugging in 3 and subtracting 0, we find that this value equals negative 18. And because here we have two actual integers, we can just plug in 6, and after doing that, we find that that equals 72. And subtracting that from the value that we found here, which we found after plugging 3 into this simplified expression, we found that that was negative 18. And so after simplifying all this, we find that the total displacement from t equals 0 to t equals 6 is 72 meters. So the actual problem that I actually got wrong in the test was part B, which asked for the distance traveled by the particle from t equals 0 to t equals 8. T equals 6. So we can simply find this by adding up the absolute values of the distances traveled in part A. So the total of this would be this value of negative 18 plus the absolute value of 72 72 plus 18. So after this, we would find that the total distance equals 108 meters.